Next given function is log of log x. Y is equal to log of log x. Dy by dx is equal to, here dy by dx is equal to log of log x. Y is equal to log of log x. So derivative of log x with respect to x. We know that, see, first we will take the derivative of this log. Okay, we know that derivative of log x is 1 by x, right? So log of log x is 1 by log x into derivative of this inside function. Derivative of log x. Okay, so derivative of log x is 1 by x. So derivative of log x is 1 by log x into derivative of log x. Okay, that is equal to 1 by log x into derivative of log x is 1 by x, right? That is equal to 1 by x log x. Okay, so here now let's find one by x into log x. Now let's find d square y by dx square. Okay, so here we will apply quotient rule and product rule. Okay, so first of all, it is of the form u by v, right? So derivative of u by v is v into denominator into, that is x into log x into derivative of 1 is 0 minus 1 into, here derivative of x into log x. Apply quotient rule, sorry, product rule, right? Derivative of product of two functions. So apply product rule here. 1 into, that is numerator into derivative of x into log x. Okay, d by dx of x into log x. Okay, in next step we will find it. Okay, so x log x whole square, square of denominator. It is the quotient rule. Okay, that is equal to, here first term will become 0 and next term is minus of, okay, let's differentiate it. X into log x, okay, derivative of product of two functions, apply product rule. X into derivative of log x is 1 by x plus log x into derivative of x is 1. Okay, whole divided by x log x whole square. That is equal to minus of 1 plus x divided by x, that is 1, plus log x into 1, that is log x, divided by x log x whole square. That's all. So it is the second derivative of the given function log of log x. Given function is sine of log x. Find d square y by dx square. That is second order derivative of sine of log x. So y is equal to sine of log x. Then dy by dx is equal to sine of log x. So first of all we will take the derivative of sine. Derivative of sine x with respect to x is cos x. So derivative of sine of log x is cos of log x into derivative of log x 1 by x. Okay, that is cos of log x divided by x. It is the dy by dx. Then d square y by dx square. Differentiate it again with respect to x. Now it is of the form u by v. Okay, so let's apply quotient rule. The denominator into x into derivative of cos log x. It is not two functions, okay, product of two functions. It is the only one function, cos of log x, not cos x into log x, cos of log x. Okay, be careful here. Cos of log x. So here let's find the derivative of cos of log x. So first of all let's take the derivative of cos, that is minus sine log x into derivative of log x is 1 by x. Okay, minus, okay, we are applying quotient rule. Denominator into derivative of numerator. Derivative of numerator is minus sine log x into 1 by x. Minus numerator into cos of log x into derivative of x is 1 whole divided by x square, square of denominator, x square. Okay, that is equal to, here x cancelled, right? So remaining minus sine of log x, it is sine of log x minus cos of log x divided by x square. Okay, that is, take minus outside, so minus of sine of log x plus cos of log x divided by x square. Next question is, if y is equal to 5 cos x minus 3 sin x, prove that d square y by dx square plus y is equal to 0. Okay, we have to prove this one. To prove this one, we need to find d square y by dx square. Okay, let's find it. So it is y, okay, y is equal to 5 cos x minus 3 sin x. Okay, y is given. Next, dy by dx. Okay, to find d square y by dx square, first of all we need to find dy by dx. So dy by dx, derivative of 5 cos x minus 3 sin x. Derivative of 5 cos x is 5 into derivative of cos x is minus sin x. Okay, minus 3 into derivative of sin x is cos x. Okay, now we have dy by dx. Next we will differentiate it again with respect to x, that is d square y by dx square. That is equal to, here minus 5 into derivative of sin x is cos x minus 3 into derivative of cos x is minus sin x. That is minus 5 cos x minus 3 into minus plus 3 sin x. Okay, that is equal to 3 sin x. Okay, 3 sin x minus 5 cos x. Just rewritten this one. Okay. So here, see what is it? It is nothing but, see what is our y? 5 cos x minus 3 sin x. It is 3 sin x, or we can write it as, here let's take minus outside. Okay, minus outside 5 cos 3x minus 3 sin x. Okay, we have taken minus outside. See what is this one? 5 cos 3x minus 3 sin x is nothing but y. Right? See, our y is 5 cos x minus 3 sin x. So it is minus 1. Take minus y this side. See, d square y by dx square. D square y by dx square is equal to, we have got d square y by dx square is equal to minus 1. Right? Take minus y this side. So d square y by dx square plus y is equal to 0. Okay? Hence it is proved. Next question is, if y is equal to cos inverse x, find d square y by dx square in term of y alone. So here our function is y is equal to cos inverse x. Okay, so here we have to find d square y by dx square in term of y. Okay, suppose if you are asked to find d square y by dx square, then you will differentiate it directly. Right? You will find dy by dx, then d square y by dx square. That is, but because we know that cos inverse x, derivative of cos inverse x is 1 by 1 plus x square, and we will differentiate it again with respect to x. So here our question is, we have to find d square y by dx square in term of y. Okay, so if you find it directly, if you differentiate it directly, that is cos inverse x, we know that derivative of cos inverse x is 1 by 1 plus x square, and you will differentiate it again with respect to x, derivative of 1 by 1 plus x square. So it is d square y by dx square will be in x terms, right? But here after that we have to write it in y terms, right? So after that we will find what is x. Here x is nothing but cos y. Then you will substitute x is equal to cos y, then you will get it in y terms. Okay, but it will be very long. So here it is the easiest method is y is equal to cos inverse x, right? So here itself we will write what is x. X is equal to cos y. Okay, if y is equal to cos inverse x, x is equal to cos y. Okay. Now we will differentiate it with respect to x on both sides. Okay. Differentiate with respect to x on both sides. So here derivative of x is 1, that is equal to derivative of cos y is minus sin y into derivative of y dy by dx. Okay. After that, okay, let's write what is dy by dx. See, take minus sin y here, so it will be minus 1 by sin y. So dy by dx is equal to minus 1 by sin y. Okay. Now let's find d square y by dx square. Now it is of the form u by v. Okay. So let's apply quotient rule here. So d square y by dx square is equal to, see, minus is here. So let's take minus outside, then differentiate it. Otherwise you will be confused. Okay. So minus into, okay, take minus outside, then differentiate. So 1 by sin y. Apply quotient rule. Denominator into, that is sin y into derivative of 1 is 0 minus numerator into, that is 1 into derivative of sin y is cos y into dy by dx. Okay, derivative of sin y is cos y into derivative of y with respect to x, that is dy by dx, divided by derivative of, square of denominator, that is sin square y. Sin y whole square, that is sin square y. Okay. So here first term is 0 and minus into minus plus. So plus 1 into cos y, no need to write, okay. Cos y dy by dx divided by sin square y. Okay. That is equal to, here let's substitute what is dy by dx we have got. So cos y dy by dx is minus 1 by sin y divided by sin square y. Okay. What is this one? Minus 1 by minus cos y by sin y, that is cot y. Okay. Minus cot y divided by sin square y. So what is 1 by sin square y? Cosec square y, right? So minus cosec square y cot y. See, our d square y by dx square is in only y terms. Okay. Next question. If y is equal to 3 cos log x plus 4 sin log x, show that x square y2 plus x y1 plus y is equal to 0. Very important question. So here we have to prove this equation, that is x square y2. y2 means d square y by dx square, second derivative of y. X y1, y1 is dy by dx, first derivative of y, plus y is equal to 0. Okay. So for that we have to find dy by dx and d square y by dx square. Okay, our y is given, y is equal to 3 cos of log x plus 4 sin of log x. Now let's find dy by dx. dy by dx is equal to derivative of first term, 3 is constant, 3 into derivative of cos log x, derivative of cos x is minus sin x. So derivative of cos log x is minus sin log x into derivative of log x is 1 by x plus derivative of this one. Okay. It is not the product of two functions, only one function, cos of log x, not cos x into log x, cos of log x. Okay. So here 4 into derivative of sin log x, derivative of sin x is cos x. So derivative of sin log x is cos log x into derivative of log x is 1 by x. Okay. That is equal to, here, minus 3 sin log x plus 4 cos log x divided by x. It is dy by dx or y1. Okay. We can write it is as y1. Okay. So next we will find d square y by dx square. So we will apply quotient rule. Now it is of the form u by v. Okay. It is numerator, denominator is x. So d by dx of this one, differentiate it again with respect to x. So denominator x into derivative of this numerator, that is x into, let's differentiate it, minus 3 constant minus 3 into sine log x. Derivative of sine is cos. So cos log x into 1 by x plus 4 into derivative of cos is minus sine log x into derivative of log x is 1 by x. Okay. Divided by, sorry, one more term is there, right? Quotient rule, that is denominator into derivative of numerator. Okay. Only first term is done. Next second term is numerator into derivative of denominator. What is the numerator? Minus 3 sine log x plus 4 cos log x into 1. Derivative of x is 1. Divided by, whole divided by x square. Okay. That is equal to, here, see, if we multiply this x to each terms, so this will be cancelled, right? X into 1 by x, that is cancelled. X into 1 by x will be 1. Okay. Then here remaining minus 3 cos log x. Okay. Here also minus 4 sine log x, cos of log x, sine of log x. Here minus become plus 3 sine of log x plus minus into plus minus 4 cos of log x. Okay. Divided by x square, that is equal to, here minus 3 cos of log x minus 4 cos of log x, that is minus 7 cos of log x. Then minus 4 sine of log x plus 3 sine of, minus 4 plus 3 minus 1. So minus sine of log x divided by x square. Okay. Now what is our y? 3 cos log x plus 4 sine log x, right? Okay. Now let's find this one and let's prove it is equal to 0. So what is x square y2? X square y2. y2 is d square y by dx square. So x square y2 plus x y1 plus y, that is equal to x square into y2. When we multiply this x square here, this x square will be cancelled. So we will get minus 7 cos of log x minus sine of log x plus x into y1. What is y1? Our y1 is this one. So when we multiply x into this term, so this x will be cancelled, right? So here minus 3 sine of log x plus 4 cos of log x plus y. What is our y? Y is nothing but plus 3 cos of log x plus 4 sine of log x. That is equal to, here let's find, say minus 7 cos log x, here plus 4 cos plus 3 cos. It is 7, right? 7 cos log x minus 7 cos log x, 0. Okay. Next sine, see minus sine, here minus sine, minus 1, minus 3, minus 4. Minus 4, here plus 4 sine log x, that is 0. So total we will get 0. So here we have got x square y2 plus x y1 plus y is equal to 0. Next very important question. If y is equal to a into e raised to mx plus b into e raised to nx, show that d square y by dx square minus m plus n dy by dx plus m into n into y is equal to 0. 2011 question. So here given y is equal to a into e raised to mx plus b into e raised to nx. We have to show this d square y by dx square minus m plus n dy by dx plus m into n into y is equal to 0. So for that we have to find dy by dx, d square y by dx square and substitute this in LHS. Then we have to show it is equal to 0. Okay. Then find dy by dx. dy by dx is equal to derivative of first term, that is a into e raised to mx. Derivative of e raised to x is e raised to x. So derivative of e raised to mx is e raised to mx into derivative of mx is m. Okay. Plus derivative of b into e raised to nx. B is constant. So b into derivative of e raised to nx is e raised to nx into n. That is equal to, okay, now let's find d square y by dx square. That is equal to, here a into m is constant. So a into m into derivative of e raised to mx is e raised to mx into derivative of mx is m. M is constant, okay. Plus here b into n is constant. So derivative of e raised to nx is e raised to nx into derivative of nx is n. Okay. That is equal to, here a into m square, m into m square, e raised to mx plus b into n square, e raised to nx. Okay, now let's substitute this dy by dx and d square y by dx square in LHS. Okay, that is d square y by dx square. What is our LHS? d square y by dx square minus m plus n into dy by dx plus m into n into y, that is equal to, we have to prove it is equal to 0. Okay, let's substitute d square y by dx square. What we have got? A m square e raised to mx plus b n square e raised to nx minus m plus n into dy by dx is a m into e raised to mx plus m plus n into, okay, so m plus n into a m e raised to mx plus b n e raised to nx. Okay, next after that plus m into n into y. Our y is a e raised to mx plus b e raised to nx. Okay, now let's simplify this one. It is a m square e raised to mx plus b n square e raised to nx minus m into these terms, okay, m plus n into these terms, right? So first of all let's multiply m by these terms. So m into these terms, that is minus a m square e raised to mx, m into this term, that is b mn into e raised to nx plus next n into, multiply n by these terms. So n in a mn e raised to mx plus b n square e raised to nx plus a mn e raised to mx plus, okay, it is minus of, okay, it is minus of m plus n. So here we have to multiply minus, okay, minus of, it is minus of, okay, minus, and it is also minus. Then here it is plus b mn into e raised to nx. Okay, see, a m square e raised to mx minus a m square e raised to mx cancelled. Then b n square e raised to nx minus b n square e raised to nx cancelled. Then minus b mn e raised to nx plus b mn e raised to nx cancelled. Then minus a mn e raised to mx plus a mn e raised to mx. See, all terms are cancelled, that is 0. So we have got d square y by dx square minus of m plus n dy by dx plus mn into y, that is equal to 0. if y is equal to 500 e raised to 7x plus 600 e raised to minus 7x, show that d square y by dx square is equal to 49y. So for that we have to find d square y by dx square. So y is equal to 500 e raised to 7x plus 600 e raised to minus 7x. dy by dx is equal to 500 into derivative of e raised to 7x is e raised to 7x into derivative of 7x is 7. Okay. Plus derivative of 600 e raised to minus 7x. 600 is constant into e raised to minus 7x is e raised to minus 7x into derivative of minus 7x is minus 7. Okay. Next we will find d square y by dx square. So here 500 into 7 into, that is constant, 500 into 7 into e raised, derivative of e raised to 7x is e raised to 7x into derivative of 7x is 7, plus here 600 into minus 7 is constant into derivative of e raised to minus 7x is e raised to minus 7x into minus 7. Okay, that is equal to, here 7 into 7, 49 into 500 e raised to 7x. Here also minus 7 into minus 7, 49 plus 49. So plus 49 into 600 into e raised to minus 7x. So 49 is common. So let us take it out. 49 into 500 e raised to 7x plus 600 e raised to minus 7x. That is equal to, see inside of the bracket it is nothing but y, right? 500 e raised to 7x plus 600 e raised to minus 7x. So it is equal to 49y. Okay, 49y. So here, see this one only we had to prove. Okay, d square y by dx square is equal to 49y. So d square y by dx square is equal to 49y. Okay, d square y by dx square is equal to 49y. Next question, if e raised to y into x plus 1 is equal to 1, show that d square y by dx square is equal to dy by dx whole square. It's very important question, 2011-2015 question. So here given e raised to y into x plus 1 is equal to 1. So to prove this one, we need to find dy by dx and d square y by dx square. Okay, let's differentiate on both sides. So here left side in LHS differentiation is product of two functions. So let's take e raised to y as first function, x plus 1 as second function. Then e raised to y into derivative of x plus 1, that is 1, right? D by dx of x is 1, d by dx of 1 is 0. Therefore, e raised to y into 1 plus second function x plus 1 into derivative of e raised to y is e raised to y into dy by dx. Okay, derivative of LHS is done. Next, derivative of RHS, that is 0. Derivative of constant is 0. Okay, so it is e raised to y plus x plus 1 into e raised to y into dy by dx is equal to 0. Now, see what is it? It is nothing but 1, right? E raised to y into x plus 1, that is equal to 1. Let's substitute. E raised to y plus 1 into dy by dx is equal to 0. Okay. That is e raised to y plus dy by dx is equal to 0. Now, let's differentiate it again with respect to x. So, derivative of e raised to y is e raised to y dy by dx plus derivative of dy by dx with respect to x is d square y by dx square. That is d by dx of dy by dx. That is equal to derivative of 0 is 0. That implies e raised to y dy by dx plus d square y by dx square is equal to 0. Okay. Then here we have to prove d square y by dx square is equal to dy by dx whole square, right? So what is e raised to y? Yes, see here, from here we will get e raised to y is equal to minus dy by dx, right? E raised to plus dy by dx is equal to 0. So from this equation we will get e raised to y is equal to dy by dx. So let's substitute here. Okay, this implies dy by dx into dy by dx plus d square y by dx square is equal to 0. Okay, that is, it is minus, okay, minus e raised to y is equal to minus dy by dx. Substituted e raised to y is equal to minus dy by dx. So minus dy by dx whole square, dy by dx into dy by dx whole square plus d square y by dx square is equal to 0, right? That implies, take this minus dy by dx whole square right side. So we will get d square y by dx square is equal to dy by dx whole square. Okay, minus will become plus. See, hence it is proved. This is what we had to prove. Okay, d square y by dx square is equal to dy by dx whole square, right? See here, we have got this equation e raised to y plus dy by dx is equal to 0. So from this equation we have written e raised to y is equal to minus dy by dx and substituted this here. Okay, or you can differentiate here itself, no problem. So after that, see, you will get the result. Look at the next question. If y is equal to tan inverse x whole square, show that x square plus 1 y2 plus 2x into x square plus 1 y1 is equal to 2. y2 means d square y by dx square, y1 means dy by dx. Given y is equal to tan inverse x whole square. Okay, we need to find dy by dx and d square y by dx square. y1 or dy by dx, y1 or dy by dx, derivative of this function with respect to x. So here derivative of tan inverse x whole square. So first we will take the derivative of in the form of x raised to n. Okay, it is in the form of x raised to n. So derivative of x raised to n is n into x raised to n minus 1. So 2 into tan inverse x whole raised to 2 minus 1, that is 1. Okay, into derivative of tan inverse x 1 by 1 plus x square. That is 2 tan inverse x divided by 1 plus x square. It is y1. Okay, or dy by dx. Next we will find y2 or d square y by dx square. That is equal to, now it is of the form u by v. So we will apply quotient rule. So denominator into 1 plus x square into derivative of 2 tan inverse x. 2 into derivative of tan inverse x is 1 plus 1 by 1 plus x square minus numerator into 2 tan inverse x into derivative of 1 plus x square is, derivative of 1 is 0, derivative of x square is 2x whole divided by square of denominator 1 plus x square whole square. That is equal to, here 1 plus x square cancelled. So 2 minus, it is minus 2 tan inverse x into 2x divided by 1 plus x square whole square. Okay, this can be written as 2 divided by 1 plus x square whole square minus, see here we will write it separately. This one we will get here 2 tan inverse x divided by 1 plus x square whole square. So I will write it as 2x divided by 1 plus x square. See, it is nothing but y1, right? 2 tan inverse x divided by 1 plus x square is y1. So it is equal to 2 by 1 plus x square whole square minus, it is y1. Okay, so 2x divided by 1 plus x square into y1. Okay, now here we have got this equation y2 okay, y2, and take this term right side, okay, sorry, left side. So plus 2x divided by 1 plus x square y1, it is equal to 2 divided by 1 plus x square whole square. Okay, now let's take this one here. We have to prove this one, right? Okay, so let's take this 1 plus x square whole square left side. So it implies 1 plus x square whole square y2 plus 2x into 1 plus x square whole square y1. Here it is divided by 1 plus x square, that is equal to 2. Okay, we have taken 1 plus x square whole square left side. So it is 1 plus x square whole square y2 plus 2x into 1 plus x square whole square 2x y1 divided by this 1 plus x square is equal to 2. Okay, here 1 plus x square cancelled, then it is 1 plus x square whole square y2 plus 1 plus x square cancelled. So 2x 1 plus x square into y1, that is equal to 2. Okay, sorry, it is 1 plus x square whole square is here, okay. Okay, so hence it is proved.